let's look at section 9.7, which then puts a bunch of our old concepts back together. So linear functions, quadratic functions, and exponential functions. So we're going to determine the difference between linear, quadratic, and exponential functions. Okay, linear functions, this is something that you did last year. To be a linear function means that we want to be thinking about the form y equals mx plus b. When you see the word linear, think of the word line in it, okay? It forms a line. So there's a lot of different ways that the line could be, but here's just one picture of what a line is. In this case, it's a positive slope. Okay? I could have had it going down. That would have been a negative slope. Could have made a vertical or a horizontal line, but these are linear functions. When we're talking about quadratic functions, this is something that we just did in this last chapter. Y equals ax squared plus bx plus c. When you have a quadratic function, remember that looks like a U-shaped graph. Exponential functions is something that we talked about at the very beginning of this semester. That would be in the form y equals a times b to the power of x. When you think about exponential, think about the word exponent. There has to be x as the exponent. So that means that it's going to have a nice curve, either rising very quickly or falling very quickly. All right, so one of the things that you're going to be able to do is if you're given ordered pairs, you can plot those ordered pairs, see what they look like, and then you can determine what kind of function you have. So remember, when you're plotting ordered pairs, x goes first, y goes second. So in the ordered pair 1, 3, I'm moving 1 to the right, 3 up, plotting my point. Then I have 0, 0, which means that I'm going to stay in the very middle. I'm not moving left or right. I'm not moving up and down. Negative 3, 3 means we move 3 to the left and 3 down. Plot my point. At negative 1, negative 3, positive 3, my bad. So 3 to the left and then 3 up. At negative 1, I'm moving 1 to the left and 1 down. And then at negative 2, 0, I'm moving 2 to the left, but then I am not moving up or down. So notice that if I connect these points, it looks like a U, which remember, we call that then a quadratic function. If we look at the second problem, at the ordered pair 0, 2, remember, 0 means I'm moving left or right. 2 means I'm moving up or down. But when it's 0, I don't want to move left or right, so I'm just going to go up 2 and plot my point. At negative 1, 4, I move 1 to the left and 4 up. At 1, 1, we move 1 to the right and 1 up. And then at 2, negative a half, we move 2 to the right. Half is going to be in between 0 and 1. So we are not going to then have a lot of room to plot it, but it's in between 0 and 1. So notice that there is a curve that's happening here. So we have something that looks like this. When you have a curve, that would be an exponential function. If we look at this third and final example here, once again, x goes first, y goes second. X means you move left or right. Y means you move up or down. Starting in the middle, at negative 1, you move 1 to the left. Negative 2, we move down 2. 0, negative 1 means you don't move left or right, but you move down 1. 1, 0 means you move 1 to the right and then stay there. At 3, 2, you move 3 to the right and 2 up. And then 5, 4, you mean 5 to the right and 4 up. Notice that these points are connecting and forming a line. That makes it a linear function. Okay, so anytime you're given ordered pairs, You're just plotting them and seeing what shape you have, and that will indicate your graph. But what if I'm not going to actually draw a picture? What if you're just given points in a table and I just ask without a drawing, what do you do? So let's go through these definitions. It says the x values of a linear function. Once again, a linear function means we're thinking about a line, will increase at a constant rate, while the first difference of the y values will increase or decrease at a constant rate, meaning by the same number. If we are dealing with x values of a quadratic function, which remember looks like that u, they're going to increase at a constant rate, while the second difference of the y values increase or decrease at a constant rate by the same numbers. If we are dealing with an exponential function, which remember kind of looks like a curve like that, kind of like a J a little bit, the x values of an exponential function will increase at a constant rate, while the y values will multiply or divide by a common ratio, meaning the same number. Okay, so let's take a look at all of this by looking at these charts. We're going to determine, just based off this and not by drawing a picture, what we're dealing with. Okay, so in every single one of these situations, we want to increase at a constant rate, meaning by the same number for the x values. So if I was to look at how do you go from -1 to from -2 to -1, well, you add 1 onto it. How do you go from -1 to 0? You add 1. How do you go from 0 to 1? You add 1. So that means that for these x values, we are going at a constant rate. It's increasing the same number each time. So now we have to figure out, well, what's the pattern for the y's? Either we are going to have the first set of differences increase or decrease at this constant rate. We'll have the second differences of these y's increase or decrease at a constant rate, or we're going to be multiplying or dividing by the same number. So to go from -1 to 2, let's look to see if we can add or subtract a number, and we can go from there. To go from -1 to 2, we're going to have to add something because we're going to a positive number. We're going to add the number 3 because -1 plus 3 is 2. So then how do you go from 2 to 5? Well, you can add 3. 2 plus 3 is 5. How do you go from 5 to 8? Well, 5 plus 3 is 8. So notice that this is the first difference. We only had to do the number one time to get to the next number. And notice that we are going at a constant rate because we keep adding the same number each time. That is the very definition of a linear function. Let's take a look at another example. Notice that if I'm looking at my x's, to go from -1 to 0, I'm going to add 1. To go from 0 to 1, I'm going to add 1. To go from 0 to 2, I'm going to add 1. So once again, we're at this constant rate for the x's, which I need for every situation to have either linear, quadratic, or an exponential function. So then let's look at the y values. How do I go from 0.5, which is a half, to 1? Well, if I tried to add it, I would have to add another half. But then notice to go from 1 to 2, adding a half doesn't make that happen. So adding the same number each time is not going to work. We have to come up with another strategy. What we should do then is, let's see if we can multiply next. If I take a half and I double it, that gets me to 1. If I take 1 and I double it, which means multiply by 2, I get 2. If I take 2 and I double it, which means that I multiply by 2, I get 4. So notice that because we are, in this case, going to multiply by a common ratio, which in this case is 2, that means when we multiply those y values, we have an exponential function. Okay, let's take a look at this third chart here. Notice to go from 0 to 1, we would add 1. To go from 1 to 2, we'd add 1. To go from 2 to 3, we'd add 1. To go from 3 to 4, we'd add 1. How do I go then from the y? So once again, that's a constant rate, and that's what I need to have in order to begin this process. So then let's look at the y's. If I look at 0 and now I'm going to a negative, that means let's try subtraction. To go from 0 to a negative 0.25, I'd have to subtract 0.25. But then to go from negative 5 to negative 1, I'm not subtracting this 0.25. I would have to subtract 0.75. So we're not subtracting the same number. If I keep going to go from negative 1 to negative 2.25, I'm not subtracting 0.75. I'm actually subtracting 1.25. To go from negative 2.25 to negative 4, I am going to have to subtract 1.75. Okay, so notice that my subtractions keep changing each and every time. However, if I look, the difference then between 0.25 and 0.75 is a difference of 0.5. To go from 0.75 to negative 1.25, that's another difference of 0.5. To go from negative 1.25 to negative 1.75, it's another difference of 0.5. So it didn't take the first numbers of subtracting to be at that constant rate. It took the second difference to be at a constant rate. Okay, if you had tried to multiplying anything times 0 would have given you 0 for the second answer, which is why I knew that multiplying and even dividing, if I divided by 0, I'm going to still get 0. That wouldn't have changed any of the numbers in the y. So that's why I knew I didn't have an exponential function, because if you have a value of 0 for the y, there's no way for us to increase or decrease by multiplying or dividing. So I knew it had to be something with adding or subtracting. Okay, so that's my thought process there. But because we had the second difference, that meant that we have now a quadratic. Okay, so try this checkpoint problem. See if you can figure this out. So pause the video and then you can push play and see my thought process. Okay, so hopefully push pause. Notice that here I would add 1 to get from negative 1 to 0. Then I would add 1 to go from 0 to 1. Add 1 to go from 1 to 2. Add 1 to go from 2 to 3. So we do have that constant rate, which I need for my x values. So now let's try to figure out, notice how to go from 1 to negative 1, you could multiply by a negative, and then if you multiply by negative again, it gives you positive, but then if you multiply by a negative, you're not going to get to another negative. So multiplying, because we only have one negative in this entire y, isn't going to get me anywhere. So multiplying and dividing is out, which means we don't have an exponential function. So let's look to see if we can do any type of adding or subtracting. To go from a positive to a negative, we're going to have to subtract. So let's subtract 2. 1 minus 2 gets you negative 1. Now, to go from negative 1 to positive 1, we are going to have to add 2. To go from 1 to 7, we're going to have to add 6. To go from 7 to 17, we're going to have to add 10. So obviously none of these numbers are the same, which means it can't be linear because my first difference isn't at a constant rate. So then let's see what the relationship between these numbers are. To go from -2 to +2, we're going to have to add. You're going to have to add the number 4. To go from 2 to 6, you're going to have to add 4. To go from 6 to 10, you're going to have to add 4. So notice that once again, it was the second difference in order to get us that constant rate, which means that we have a quadratic.